and relative molecular mass. First, we have to learn these both concepts, and then we will be going for the mole calculation. Okay. Now, this relative atomic mass and relative molecular mass just has one equation. You just have to know the equation and to substitute on. Okay. So when you take the relative atomic mass or the relative molecular mass, now what's the difference is relative atomic mass is for atoms, that means just single elements like sodium, then magnesium, aluminium. Likewise for single elements, we define the relative atomic mass. Okay, this is basically the mass of it. Okay, mass of the elements. If it is a molecule, now molecule, it is composed of more than one element. Okay, a molecule is composed of more than one element. For example, we can take carbon dioxide. You can also take O2. This is also a molecule. It's not a element. So you should know the difference between molecules and elements. Elements is just single one component, but molecules are made up of two or more elements. So you can take NH3. Likewise, you have different atoms and molecules. Now, in this lesson, we are going to analyze their mass. Okay, mass, and then we will express their mass in the concept called mole. Okay. Now, in order to calculate these atomic mass and molecular masses, there is an equation. So you will take the mass of the element or compound. Compound is basically the molecule. And then there's a standard. Now, whenever you get the name relative, we are always seeing the mass of an element or compound relative to a standard. Okay. So already the chemistry people, they have taken the standard as 1/12 the mass of carbon. Okay. So you are relative to this, you are seeing how much is the mass of the element. Okay. For example, let's say, this is just for an example. This is sodium. Now, sodium's mass is, let's say it is 24 grams, just for example, okay? And our carbon, okay? Our carbon, let's say it is 12 grams. Now, when you consider relative to carbon, can you understand sodium is twice? Relative to carbon, sodium's mass is twice. So that's how this equation also comes. Relative, but here we are taking relative to the what? 1/12 the mass of carbon. That is the standard. You don't need to know why it came. But relative to this, we will divide by the mass of that element and take the relative atomic mass or the relative molecular mass. So you need to know the equation because they will give this data, okay, and then ask the correct substitution. Okay, so we'll see for the past paper MCQs. You have to keep this equation memorized. So this is how we are seeing the relative atomic mass or relative molecular masses. So you should remember this equation. But for us, everything is pre-calculated. Come to the next page, 125. Yeah. Can you see that table? So all the elements, the relative atomic mass are calculated. Okay. Hydrogen is 1. You can see calcium is 40. Okay. So everything is calculated based on this equation. So you don't need to how substitute and calculate. But you should know the equation. Okay. So everything is pre-calculated and these values also in the exam they'll give. You don't need to memorize. Okay. Everything will be given. So, but you should know the concept. This equation you should know. Yeah. So I want to copy this equation now. So you can put the seventh lesson topic and copy the equation of that equation. Okay. Okay. Now we'll see. Now in this equation, there is one question point, that is you are getting a MCQ pattern. Okay. So let us learn that. So they have given us some data that mass of oxygen is 1.2.668 10 to the power minus 23 grams. Now you can see how very small it is. 10 to the power minus 23 means this decimal will go behind 23 times. So it's like 0.000, very minute amount. Okay, masses. That's why they put in this scientific notation. So the mass of carbon 6, that is 1.9 grams. Now they are asking the relative atomic mass of oxygen. Okay, so first one I'll do. So they're asking the relative atomic mass of oxygen. Now you know the equation, right? The relative atomic mass is equal to, what's the equation? You should have the mass of the element on top. So mass of the element means the element they are asking for. From here it is the oxygen. Therefore it is 2.66 into 10 to the power minus 23 on top. Then you remember the denominator 112, the mass of carbon. So you have to first put 112. What's the mass of carbon? 1.9 milligram into 10 to the power minus 22. So this is the answer. Okay, so you are not expected to calculate this. Okay, so in the MCQs you will have different. Now this is the correct variation. Now you'll have different variation. They might put 12 on top. They'll put this bottom. You have to just pick the correct substitution only. Okay. So first you write this as an example. After I'll give you one word. Mhm. Yeah. Okay. Now let's see one other. They have given the mass of potassium 6.4 minus 23, and this is again 1.9 So you have to find the relative atomic mass of potassium. So just substitute, okay? Same like earlier. Okay. So you should have get 6.476 into 10 power minus 23 on the numerator. And on the bottom, you should have 112 the mass of power. Got it? Okay. So that is the question point on this. Same way they can give this for molecules also. Now molecule or atom, same equation, okay? No difference. Now instead of potassium, you can have molecule. Now molecule means it should trick your mind that it is made up of more than one element. Okay, now let's take a molecule. Okay, they have given water. So mass of water. Water is what? H2O. 2.99 into 10 to the power minus 23 grams. All in grams. So now they will ask the relative molecular mass. Now earlier I put RAM because it's atom. Now it's molecule. Okay, relative molecular mass of water they are asking. So very simple, the same equation. Okay. So in the numerator you should have the mass of water. Now you will have mass of water on the numerator. Into 10 power minus 23 over 1 divided the mass divided by 9 into 10 power. Okay. Now see on numerator you have gram, in denominator also you have gram. So both these gram will cut. That means this has no unit. Relative atomic mass or molecular masses, there is no unit. Okay. So copy this down. Amen. 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 Nasa pula para ko ba? Okay. Done. So they can give this for both molecules and water, but it's the same equation. And then now write this point. Okay. So I started the first part of this lesson, so we can do. Notes? Yeah, take down this. How many pages want to do that? This one page. Wait, I'll tell you the. So I'm writing this topic, okay? Write this topic. Okay. Now we are going to see how to calculate the relative molecular masses of compounds. Okay, so this is coming for compounds only. Now in your book, in the third page of this lesson, they have given all the relative atomic mass values of the elements. Okay, for each of the element, they have given the values. Keeping that, we can find the relative molecular masses of compounds. Okay, so I'll do a few examples. So I'll take water first. Now you are getting a question to calculate the relative molecular mass of water. Okay. Then they will give in the bracket the atomic masses. Now hydrogen's atomic mass is 1. Oxygen it is 16. Okay, they'll give the values. Okay, you don't need to memorize. So they will give the each element's atomic mass they'll give. And then they'll tell you to calculate the molecular mass. Now, this is important because for the mole calculation, this is coming. Okay, so it's very important you get the basics of this. So you have to take now each element. Okay, now you have how many hydrogens in this? Two. Water molecule has two hydrogen and one oxygen atom. So now first you have to take the relative atomic mass of hydrogen, which is 1, and then multiply it by 2 because you have two hydrogen atoms. And then you have to take the relative atomic mass of oxygen. Now here you have only one oxygen, so just 16. So what you do is you take the sum of relative atomic masses. Okay. In the molecule, you take the sum of the relative atomic masses of the each element. So you add up. Okay, then 2 plus 16, it is 18. Okay, therefore relative molecular mass of water is how much? 18. Now we learned the equation, right? Relative molecular masses have equations. Mass of the compound over 1/12 the mass of carbon. Okay, that's the relative molecular mass equation. So that's the first thing we were learning. When you solve that equation, you're going to get 18. Okay, but this is way easier, right? Because that equation is a bit complicated. Okay, so to find for molecules, it's very simple. You have to take the atomic mass and add them up. Okay, this is also one MCQ point they used to ask. Now let's see another element, carbon dioxide. The carbon is 12. Oxygen it is 16. Okay. Now again, you have to take the sum of the atomic masses. You have one carbon, which is 12. You have two oxygens, therefore 16 times 2. So you get 4. Okay. This is the molecular mass of what? Carbon dioxide. This is the molecular mass of water. Likewise, now if they give any compound, you can find. You just have to add up. Okay. Is that clear? Any doubts? Okay, now take up this example. After that, I'll give you a list of compounds to calculate. Okay. Okay, done. So now I'll give you some compounds you have to calculate. So, now this one's relative atomic masses. Okay, refer in your textbook. Here, page number 125. Okay, we have the relative atomic masses. So you can refer them. So I won't write them. So first see what are the different elements and find their radioatomic masses. And then you have to see the quantity, how much you have. Either it's one, two, and then add up. Okay, that's it. You will get big compounds also. Now this is glucose. It's A6H12O6. This is sucrose. This is alcohol. Yeah, fine for this. So first one is ammonia. Ammonia is 14. 14 plus 3. You should get 17. Okay. Oxygen is 16. So 16 times 2, 32. Nitrogen is 40. So 28. Chlorine is 35.5. So 4 it would be 144. 144 plus 12, no? 156. This is 100 calcium carbonate. Magnesium 24, 32, and 64, no? 90, 110, 120. 120? 90, 100, 110, 180, 120 all got two different. 120, no? Sulfur dioxide is 64. 64. We can do the other three. Also finish. Okay. Glucose, I think you should get 180.
Yes.
Okay. Next one. How much you got?
162.
Check that. Way. So, 340. We'll check it. Yeah, 340. Take your calculation.
And that one also got that 156 calcium.
CCl4. 12 plus 144.
Yeah, it's kind of 144 from the equation. Oh, it's 4.
Oh yeah, 142. Yeah, it's 154. Others? Okay. 32, no, last one. Okay, now check it. Okay. Last one, 32. Okay, no? So this is how you calculate the relative molecular masses when the relative atomic masses are given. So all the relative atomic masses will be given. You have to add them here. Now, before going to the mole calculation, you should know concept called molar mass. In molar mass. Okay. So molar mass is having a unit. Now, relative atomic mass, relative molecular mass, they didn't have units. Okay, molar mass has a unit that is gram per mole. That means 1 mole of any compound you take. Okay, 1 mole of any compound. How much in grams? This is molar mass. Okay, 1 mole of any compound. How can you express it in grams? That is molar mass. That means grams per mole. 1 mole has how much of grams? That is what we are going to see. Now, this is very easy. This is actually equal to relative atomic masses or relative molecular masses of the particular compound or element. Okay, now look at this. Sodium. Sodium's relative atomic mass. Check in the table, I think it's 23. 23?
Yes.
Sodium is 23. Then what is the molar mass of sodium? 23 grams per mole. Okay. The relative atomic mass of the element is its molar mass. That means if you take 1 mole of sodium, how much it will weigh? 23 grams. Did you get the point? Okay, now let's say dozen. Dozen is equal to how much? 12. Anything 12 we call a dozen, right? Likewise, 1 mole also like that, collective name. Okay. So 1 mole of any compound, but it's not constant. Now dozen means always 12 no. But 1 mole will differ from element to element, compound to compound, it will change. Now since sodium's relative atomic mass is 23, 1 mole of sodium is how much? 23 grams. Likewise, we can take it for any element. Okay, now I'll take carbon. Carbon's relative atomic mass is 12. Therefore, it's 1 mole of carbon is how much? 12 grams. 1 mole of sodium is 23 grams. But 1 mole of carbon is 12 grams. Then, same way, we can apply this for what? Molecules. Okay. Now, carbon dioxide. In one example, we calculate its relative molecular mass, right? Now, see, this is atomic mass. This is relative molecular mass. Be very familiar with these two words, okay? They're not the same. It is 44. Okay. Now how do you calculate that? You take the relative. Now you did just while ago that way. So the carbon dioxide's molar mass is how much? 44 gram per mole. That means 1 mole of carbon dioxide is 44 grams. So it changes from element to compound. It changes. So this is how you will get calculations also. Now ammonia. So it was 17, right? We calculated relative molecular mass. It was 17. Yeah, for ammonia's molar mass is how much?
17.
Gram per mole. Okay, it's very simple. So for any, that means you should know what? You should mainly know this relative atomic mass and molecular masses. Then you can work out any sum. Okay. So remember 1 mole of sodium is 23 grams. Same way now if 1 mole is 23, what do you think is 2 mole of sodium?
46.
46. So that's how they'll question you. Okay, they'll ask how much is 2 mole of sodium. They can ask half a mole also. Now see, carbon 1 mole is 12 grams. Half of it will be 6 grams. That is the question point. Okay, they'll give you the moles and ask the mass. Or else it can be the other way. They will give you the mass and ask the moles. Now I'll ask how much moles is 12 gram of carbon. What will you say? What is the moles of 12 gram of carbon? 1 mole, right?
Yeah.
Do you get it? It's 1. Okay. So if I ask 24 grams of carbon, 2 moles. 36, 3 moles. If it is 6 grams,
Half.
half. Did you get the point? Yes, 0.5 moles. So they can give the mass and ask moles, or give the moles and ask mass. Okay. So for that, you should know molar mass. So to know molar mass, you should be very familiar with relative atomic mass and molecular mass. So if you take the relative atomic mass or molecular masses in grams, that's actually the component in 1 mole. Okay, did you get it? So copy this, we'll do some sums. Okay. Now we do, molar mass calculations. Now, whenever you are writing molar mass, you must put this unit. Okay, otherwise you won't get marks. Now calculate the molar mass. Okay. Now calculate the molar mass also. Again, same thing. You have to take relative atomic mass or molecular mass and put the unit. Okay, the same thing, but put the unit. Okay. Okay, now magnesium, you can see in the table, its relative atomic mass is 24, I think. Okay, it's 24. So what is the molar mass? 24 gram per mole. Okay, that is the, you have to put this unit, G per mole. Now for these, then you have to calculate the molar masses and then put the unit. Finish. So nitrogen dioxide, it has to be 14 plus 32, no? 46 gram per mole. Here 32 and 40, 80 gram per mole. 16 gram per mole. 71 gram per mole. Okay. Got them all? Now you can see there is a nice relationship, right? You know, if you know the grams, you can find the moles. Same way, if you know the moles, you can find the grams, right? So all of these, we are mending them into one equation. And if you go with the equation, it's very easy, okay, all the time. So this is the equation. N equals simple N over capital N. If you follow this, we'll never go wrong in the calculations. Simple N is small, but its unit is mole, MOL. Okay, this is the name of it. But when you are writing like 1 mole, you have to put MOL only, not E. Okay. Then simple M is mass. So it can be either element or compound. You take it grams. Capital M is our molar mass. And you should understand this molar mass is something always you can find it. They'll not give in questions. Because you can find it, no, they give the relative atomic masses. You can add up and take it. Okay. So they will not give molar masses. So this always you know. That's the point here. You always know the molar mass. So they will give the moles and ask you to find the mass, or else they'll give the mass and ask you to find the moles. Either way only they can ask. Okay. Based on this equation. So following this equation is very easy. Okay. First you note down the equation. So after that I'll show you how to use it. Okay. Now we'll see how to use this. So this is how you are going to, most of the time you're going to get questions like this. Find the moles of 36 gram of water. Now, if you want to find moles, but you have to find the simple N, right? So first always write the equation. Simple M over capital N. Now you have to find what? Moles. Moles is equal to mass divided by the molar mass. That means now you need two data to find moles. But you need the mass and the molar mass. The mass is already given. Can you see here? This is the mass. 36 gram of water. But molar mass, I told you, they'll never give it. You have to find it with the given information. So how do you find the molar mass of water? Here, can you see they have given the atomic masses? So you have 2 hydrogens plus 1 oxygen. How much? 18 gram per mole. Did you get it? Is it clear? You didn't get it? Okay. So now we learned about the molar mass, right? In the previous steps. You remember? So what is molar mass? If you take the relative atomic mass or molecular mass in gram per mole, that is the molar mass. So that is what here in this equation. So in order to find this molar mass, you have to see first what's the compound given. Then now they have given water. Then water directly you don't know, right? What you should do, you have to add and take it. So how do you identify? Hydrogen is 1, 1 times 2. Oxygen is 1, that is 16. So 80. Now, okay. So I told you that this one, if you put this unit, what is that? That is the molar mass. That's the molar mass. That is what they are in this denominator. So they'll not give this one. They'll give like this some data. You have to add and take. Now sometimes it might be sodium. Then directly you can put the number. But if it is a compound, you have to add and take. Now clear, right? So now what is on the numerator? Mass 36 gram. What is the molar mass? 18 gram per mole. Now in the essay questions, you have to work out like this. But here units are not necessary. You can just put 36 over 18. So when you divide it, how much? 2. No? And mole. Understood now? Okay, so this is how you calculate moles. If they give the mass. Other way also possible. First we'll learn this method. Is that clear, everyone? Okay, then take this example. I'll give you a few to work on. Okay. Now you have to work few other. So write the equation, substitute, and take the final. Okay. So the relative atomic masses, use the table in the book, okay? First work for these three. You have to find the moles. Finish. Now here, first one, 23 gram of sodium. So moles equal to simple M over capital N. The simple N is how much? 23 grams. So what is sodium's molar mass? I think that's also 23, right? So 23 divided by is 1 more. Got it? So make sure you have put the unit, okay? Without unit, no marks. So that's for the first one. Second one is 88 gram of carbon dioxide. So simple M over capital M. Simple M is 88. Capital M, I think it should be 44, right? Then it is how much? 1 and 2, no? 2 moles. 2 moles of carbon dioxide. Next, third one. Moles equal to simple M over capital M. The mass of magnesium is 12, but I think molar mass is 24, right? So did you get half? 0.5 more. Okay. Got it? Any doubts? Fine. So we practice for few more compounds now. Then we go for a bit bigger compound. We can work with 30%. This is O3. Okay. Okay. And Okay. Now first it is 50 gram of calcium carbonate. So you know you have to write the equation and substitute 50 over 100, right? Did we get 0.5 moles? 0.5. Okay. Here 360 divided by 180. Here 32 divided by 64. Did you get 0.5 mole? Okay. Now here 12 gram divided by, now O3 is, this is ozone. Okay. 16 times 3, I think 48. So here 1 and here 4, you should get 0.25. Did you get 0.25? 1 divided by 4. Then here 95 divided by 95, no? 1. Okay. So this is how you will find the moles if the mass is given. Okay. So they'll give the mass and ask you to find the moles. And there, you know, the third component, molar mass, that you should be able to take it. Okay. They won't give that, but they give you the relevant data to find it. The radioatomic mass will be given. Now I told you other way also possible, right? You can find the mass if you know the moles. So let's see the other way. Now here, if you want to find the mass, you have to do a small modification in the equation. So you will have to find this. You have to find what? Simple. Now this one always will be given. They'll never tell you to find it because you obviously know it now. So now you have to find this. Then you have to do a small modification. Now in maths also you might have learned subjecting the equations, right? So you have to make this simple m alone in one side. So you take this capital M to the other side. So this side it is divided. When you take this side, it becomes multiplication. Okay. So simple m is equal to moles into molar mass. Okay. So this is what should be there in your mind. So let's see. So see the first example. I'll take 2 moles of nitrogen gas, N2. Now I have to find the mass of 2 moles of N2. Okay. Then mass is equal to what? Moles into molar mass. Now moles they have already given here 2 moles. What is the molar mass of nitrogen? Now nitrogen, you have how many nitrogen atoms? There is 2. So 1 is 14. Okay. 14 multiplied by 2 is 28. And if you put this unit, it is becoming what? Molar mass. The same thing. Okay. So 28. So 2 into 28, how much? 56. 56 grams. Because now you are finding the mass. Now can you understand this is the molar mass of nitrogen now? Molar mass of nitrogen always give the mass of 1 mole, right? So 1 mole of nitrogen is 28 grams. So 2 moles will be what? The double of it. So equation is giving it easily. Okay, rather than going with this, with the equation you can easily work it out. Okay. So either to find mass or moles, always go to the equation. Okay, now moles you learned how to find, right? Now mass is a small modification for the equation and then you substitute and take the final answer. We'll take another compound now. Okay, 9 gram of water. You have to find the moles of 9 grams of water. Sorry, mass. 0.5. 0.5 mole. Okay. So now mass is equals to moles into molar mass. So moles they have already given 0.5 moles. Molar mass of water, how much? I think it's 18. 1 into 2 plus 16, it is 18 grams per mole. Okay. So this is half, no? Half into 18 is how much? 9. 9. Is that clear? Any doubts? Okay. So yeah, take these examples, we'll work out. So, okay. So now I'm giving you creative work alone. You have to find the math, okay? So first one is 2 moles of oxygen. So here 2 has to be multiplied by 32. You should get 64 grams. Here 0.5 into 100. You should get 50 grams. Here it is 0.1 multiplied by 58.5. So you should get 5.85 grams. Did you get this? The third one? 5. What about you? 5.8. So here when you are multiplying by 0.1, now disregarding decimal, you just have to multiply by 1 first. Okay, 58.5 into 1. And then you can see here 1 decimal point has gone backward now. Here also you have to take 1 backward. 5.8. So here 4 multiplied by 71. 284 grams. Okay. Then 3 into NH2. 60. 48 grams. Here 1 into 44. 44 grams. Here 0.25 into 48. You can get 12 grams. Here 2 into 60. 32 grams. Here 3 into 103. 309 grams. The ninth one. Next one. 2 into 2, no? 4 grams. So this is how you calculate the mass. Okay. So what we have learned today is relative atomic mass, relative molecular mass, and how you can calculate and take the relative molecular masses. Then relative atomic mass, molecular mass. If you put the unit gram per mole, it is the molar mass. After that, everything is like connected. So it's in an equation. N equals simple M over capital N. So if they have given the moles, you can find the mass. If they have given the mass, you can find the moles. Molar mass will be always like you can get it. They will not ask you, but they can ask in a separate MCQ. Like the molecular masses and all. And with the first part, that equation substitution, that also they can ask. So this is the main part of this lesson, using this equation, okay, to find moles. The next part of this lesson is Avogadro's constant. You might have come across with that part. So we can continue that in the next class. Okay?